Okay, this is lesson 3.5, solving quadratic equations. The focus of this lesson is going to be solving quadratic equations and getting exact solutions, so not working with decimals. And in order to do that, we need to kind of revisit the radical stuff that we did in our last unit. Also, when you're solving equations, solution to an equation is the x value that satisfies the equation. And if we move all terms to one side and we end up with 0 on one side, it would be all the x values that give us 0. When that's the case, they're referred to as zeros or x-intercepts if you're going to graph it. In addition, any solution that you get that doesn't work in the context of a word problem, you can say is inadmissible. Like, say for instance, we were solving for time, and the variable in the function was a time. And we got two answers. One was -1 and one was 4. We would ignore the -1 in terms of time because time only travels in the positive direction, and that -1 time might be inadmissible, which means that it just doesn't work in the context of the question. So we always want to check to make sure our solutions are admissible, and when we have word problems, we need to focus on that. So we'll revisit that in future lessons. But for now, exact solutions. Exact solutions mean no decimals. So what's that mean? Well, we come across approximate solutions when we can't square root things evenly. So for instance, if we had this radical that we need to simplify and we wanted to write the exact solution, we would simplify as best possible. We've got 3 root 2x minus root 2x plus root 3x. And in terms of like terms, we have two terms with root 2x, and we have one term with root 3x. So the first two terms are in fact like terms. So we can add and subtract them. So I'm going to do that. 3 minus 1 gives us 2 root 2x. The x, or the root 2x, you can treat as kind of like a variable, and then you're just adding or subtracting the coefficients in front. And we also have a root 3x. Now, if we wanted to write this as an exact solution, we could look to see if there's anything common and make it a little bit simpler. And x is common, so I'm going to common factor an x and say 2 root 2 plus root 3. And that would be as simple as we could make this, and that's in fact an exact solution, even though it's not really a solution. It's an exact answer to the question of simplify, plus root 3. But the key is we don't have any decimals. If we wanted an approximate solution, well, we would just type in 2 root 2 plus root 3, and we'd actually get a value, and we could say that value x. So let's do that. 2 root 2 plus root 3. Now this calculator works in exact value, so it keeps it the same. It actually switched the terms order. If we wanted the approximate solution, I do need to hit the change button here to get an approximate solution. 4.56 approximately would be this number in brackets. So we could say an approximate solution would be 4.56x. The key difference here is that we use roots to express an exact answer. We didn't round anything there. All those decimals are contained within those roots. Here we've rounded. We've actually evaluated those roots and got an approximate answer. So we're going to solve some quadratics, and we're going to get exact answers only. We're going to do 2, and I'm going to leave 1 with you. So the first one says x plus 3 squared equals -2x. In order to solve this, we need to expand, collect like terms, and then look to see if we can factor. And if we can't factor, we use the quadratic formula. And the quadratic formula is usually where we end up with our approximate solutions. So let's work through the example. X plus 3 squared, we're going to expand that out. X plus 3 times x plus 3 equals -2x. And FOIL this out. X times x is x squared. X times 3 is 3x. 3 times x is 3x. 3 times 3 is 9, equals -2x. Now we're going to collect like terms, and we're going to collect them all on one side. So I'm going to move that 2x over by adding it to both sides. X squared doesn't have any like terms. 3 and 3 is 6, and when we bring over the -2, it becomes positive. So 3 and 3 and 2 would be 8. And there we have quadratic, and we look to see if we can factor it. So we look for numbers that multiply to 9 and add to 8. The numbers that multiply to 9 would be 1 and 9, or -1 and -9, but neither of those add to 8. They add to 10 and -10. 3 and 3 would multiply to 9. That would add to 6. -3 and -3 would add to -6. So we actually don't have any way to factor this. So I'm going to write here, cannot factor. You don't have to do this when you're solving. If you can't factor, you have to use another strategy, and that other strategy would be the quadratic formula. So, quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac, all divided by 2a. And if we go up here and we look at what a, b, and c are, and write them off to the side, a would be 1, because it's the number in front of x squared, b would be 8, the number in front of x, and c would be 9, the number at the end, the constant term. If some of those terms are missing, like say there was no x term, then b would be 0. If there was no constant term, then c would be 0. Yeah. So let's plug in our 1, 8, and 9 and see if we can solve here. X equals -8 plus or minus the square root of 8 squared minus 4 times 1 times 9, all divided by 2 times 1. I'm going to simplify that as much as possible. So we've got -8 in front, plus or minus. I'm going to do the whole under the root at the same time. Under the root, 8 squared, 64. 4 times 9, 36. If we subtract, we get 28. So root 28 over 2. And now we look to simplify that root as best possible. And to do that, we look to see if we can simplify the radical. Well, we can simplify that radical into 28 could be simplified to 4 times 7, and you can square root 4, you get 2. So we can simplify this to 2 root 7. And now, since we have 2 as a common factor to both of these terms, we can divide both of them by 2. You can't just divide one by 2, you have to be able to divide both by 2 to simplify. -8 divided by 2 is -4, plus or minus 2 root 7 divided by 2, the 2's would divide away, and we're left with root 7. And now we can express our two exact solutions. Our exact solutions would be, our first one, x equals -4 plus root 7, and x equals -4 minus root 7. Those would be our two answers. And in the context of like us graphing those, like say we were just given this quadratic and asked to graph it, these aren't super useful. So that's why we've always been converting to decimals so you could approximately graph those x-intercepts. But in this case, we're not looking for x-intercepts. We're asked to solve this equation. And the solution to this equation is not x-intercepts. The solution to this equation is roots. And those roots, it doesn't matter if they're decimals and easy to graph because we're not graphing them. They're algebraic solutions. So we might as well keep them as exact as possible, and those are our exact solutions. This is the simplest radical form. Let's try B. For B, we've got 3x squared minus 5x equals 2x squared plus 4x plus 10. We want to collect all those terms on one side of the equation. I usually move the terms to the side with the biggest coefficient on the x squared term because it makes the math a little bit easier. We'll keep the sign on x squared positive. So I'm going to move all my terms to the left. We got 3x squared minus 2x squared minus 5x. Really shouldn't have wrote that equal sign. All right, I'm going to try to put this in here. Minus 4x, and bring the 10 over, minus 10 equals 0. That's pretty sloppy. My equal signs don't line up. But let's simplify it. We'll line up these equal signs. 3x squared minus 2x squared is x squared. Minus 5 minus 4 is minus 9. And minus 10. And now we're looking for numbers that multiply to negative 10 and add to negative 9. And this time we can factor. The numbers that multiply to negative 10 and add to negative 9 are negative 10 and positive 1. So we got x minus 10 and x plus 1. And when you can factor, the roots are much easier to come by. You take each of your factors and you say that factor, if it was to equal 0, what would x be? In this case, x would be 10, and that's one of our solutions. And nice thing about factoring and getting your solutions is they're going to be exact. And we don't have to work with radicals either. So hope you can factor, because it makes it nice and easy. Minus 1, and there's our second solution. So if you can factor, you'll get roots that are nice and you don't have to use radicals. But if you have to use a quadratic formula, you're going to potentially, not always, end up with radicals that we have to simplify and write as our exact solution. So nice numbers like this, that's an exact solution, no decimals. Radicals like this, that's also an exact solution, and you're going to come to appreciate how nice those numbers are. There's one example left. I want you to expand, collect like terms, and try to solve it and factor if you can, but if you can't, use the quadratic formula and simplify those radicals. I'll put the answers up on the course website so you can check them. And that's it for lesson 3.5. Thanks for watching, and I'll see you next time.